with the lesson number 5, which is talking about dose response. Now, I would love to first of all give a rationale of this topic, or this component rather, its importance, its application, so that even as we discuss, at least we'll be able to link to real life situations, as well as it's real life application, as well as how does it affect our life. Yeah, because some of these things we just see them, we don't get to have an understanding of why certain things happen that way. To start with, the dose response is a topic that will be giving us highlights of how certain pollutants, not only pollutants, even drugs are able to affect human beings as well as organisms in different ways. Not only that, it will also help us to have an idea, why is it that there are some people, you are drinking beer together, 2 bottles of Castle, God knows, I've never taken that. Something that I've just seen, something that I've heard. 2 people are taking bottles of Castle. This one, just 1.5 is already drunk. The other one is half sober, half drunk. But you are drinking together, same amount of beer, same content found therein. Why? It is because of some effects that we're going to look at even in here. Then the other thing is, why is it that when 2 people are sick, the father and the mother, the father and the daughter, they both go to the hospital, they are suffering from the same disease, they'll be given the same drug maybe, and then there'll be instructions to say, let the father be taking 2 tablets of Panadol in the morning, 2 tablets in the afternoon, and 2 in the evening. But they tell the baby that you just cut half of it, you administer it to the baby. Why not the same amount? It's because of some of the reasons that we'll be looking at in here. And then the last point that we need to get reminded of is that, why is it that maybe the father and the daughter, like the same example that I'm giving, they are given the medicine, they can never tell them that, since you've been given 12, 12, 2 in the morning, 2 in the afternoon, and then 2 in the evening, that's 6. Within 2 days, you'll be able to finish these tablets given to you. Why is it that the dad cannot say, I think I'm just going to take the mate, go? No, you need to take as prescribed. Why? It is because of some of the reasons that we're going to look at in this discussion. So this topic is very, very important in our real life situations. Some of these things, we just see them happening, maybe without knowing the reason why it's done like that. And the last, though I thought that was the last part, this is the last. Why is it that when someone is sick and then they go to the hospital, the first thing they do is they take the body temperature. They also take the years, the age. How old are you? They want to know how old someone is, helping them, one of the reasons, to getting to know how much blood that person is likely to have. In certain extremely measures, you find that they even do the body weight. They put that person on a scale. Why? Because the body mass is also important in getting to know how much a drug a person can take at a go. So those are very important stuff that we need to link to our today's discussion. So they're saying the toxicology of science is based on the principle that there is a relationship between the toxic reaction, which is the response, as well as the amount of toxicant, which is the dose that a person receives. But allow me to rewrite this sentence, or allow me to bring it in this way, that there can never be a reaction without the dose. So this comes first. First thing first, a person has to be given the dose or the toxicant, even the drug. Yeah, we've heard of me when I take such medicine, I have side effects. Side effects can never come minus being given the dose. So in toxicology, that is basically what this discussion will be based on. First of all, someone has to be given a toxicant, or someone has to be given the drug, or someone has to be given a dose, or the concentrated substance. Then thereafter, we expect to see the results. Now, before we go to that, we need to understand the fact that, like I earlier indicated, that different people will respond differently to drugs. A good example I gave, that of beer. You can have the same amount of beer, same type, but one person will be drunk, then the other person remains sober, half drunk. Why? Because different people will respond to drugs differently. And then the other thing is that if a person takes much of the dose at a go, there are likely to be more severe effects than there can be on a person who takes the same amount of dose on different time intervals. So those are some of the assumptions that we're going to look at in the next few slides. Then the other thing is that concerning people responding differently to drugs, the good example that we can look at is that there are some write-ups that are there which give us which do give us the indication that some of the diseases, let me say STIs, when two people who tend to act married in an unprotected way, you find that there are some allegations, I don't know how true that is, but I believe it is, that STIs other than HIV is likely to manifest first on a man than on a woman. Why? It is because of the fact that different bodies will respond differently to such kind of vices. And then above all, one thing we need to understand is that these toxicants that we will be talking about today, some of them are likely to cause damage very fast, and others take a little bit of time for the effects to manifest. How do we bring it to our home level of understanding? HIV, which is the virus, we are going to put it maybe in form of a dose. HIV being administered to this individual, for the effects to be seen, by then, those days when there were no ARVs, for the effects to be seen, it used to take years. But COVID-19 is said to have been manifesting, to have been having the effects seen within a short period of time. So because of that, we will be looking at if two pollutants are reported to have been contaminated in a specific area. How do we get to know how intense the effects are likely to be? So we're going also to look at the different start methods that we can use to deal with the situations where the dose that is likely to bring the effects within a short period of time and those that might take a little bit of time. How can we look at the differences in those lines? So that is basically the rationale, or rather the review of the discussion. So those are some of the things that we're going to be meeting every now and then we discuss them as we go further. So there are important assumptions that have been given right over here. I think some of them have been talked about, saying there are always the dose which no response occurs or can be measured. Oh, I forgot about this. This brings us to what we call the threshold. Yeah, this brings us to what we call the threshold. There are times I think you can concur with me. You are very, very hungry, and then someone gives you very small stuff, maybe like half the size of a smaller carpenter. And no, because you are hungry, please may you just kindly take this and have it it's going to bring it's going to help you out. Look at the size of the carpenter and how much hunger someone has. You can't even feel it. Even these drugs, there are times someone takes maybe just 3/4 or maybe 2/3 of, or maybe 1/10 of the bottle of Fanta. You can't even distinguish whether this person is drunk or not drunk. So there are always at times when a certain amount of drug is given to a person, certain pollutants are given to a person, you can't even detect it. Bringing it to our home level of understanding, some of us are allergic to dust. There are times you just pass through dust, you get home, you can't even feel it. The same dust, be exposed to it for a little bit of time, you get home, you have flu. That is what that point is saying. And they're saying, once a maximum response is reached, any further increase in the dose will not result in the increased effect. We're going to look at that point later as we go on. Now, there is a difference between the dose response as well as the concentration response. The pollutants that are likely to bring effects in living organisms could be aquatic creatures, could be mammals, could be human beings, could be any kind of an animal. That dose may be given, or that pollutant may be quantified in form of a dose. And now, this dose, mostly in toxicology, when they use the word dose, they are talking about the pollutant which is in a solid state. That's one thing we need to know, because later, sooner or later, we'll be looking at the LD50, LC50. So there will be D for dose and there will be C for concentration. So the foundation has to be laid now. When you say dose, we're talking about a pollutant which is in solid state. And we know something in solid, we measure them in kg. If they are very small, you can measure them in grams. Very small, you can measure them in milligrams. And then very small, we have micrograms, such kind of stuff. That's when you bring in the issue of ppm, particle per million, ppb, and stuff like that. So when you hear of the word dose, you're talking about the pollutant that is in a solid state. There are times someone might inhale lead in solid state. Remember last time we were talking about dust. Yeah. And then there are also at times these pollutants might have dissolved in the liquid. Yeah, and when they dissolve them, they are dissolved in a liquid. They form a solution, and that solution is in a liquid state. So when they use the word concentration response, if you're talking about a concentration response curve, then we are talking about this pollutant concentration. So we're talking about this pollutant which is in a liquid state. So when we come to look at now the LC50, we'll be looking at the lethal concentration. That is, and I'll come and explain that later. So those are the things that we need to know. Okay, now when you say dose or concentration response, what are we talking about? So we're talking about coming up with a relationship that describes the quantitative relationship, the quantity, we're talking about the amount of the dose that a human being is exposed to, as well as the response in terms of the effects that that toxicant has brought about. How do I bring it to our domestic or home level of understanding? Let's look at what's this? Let's look at Piriton. Piriton is a very good drug, but now in our dose response, we are trying to look at how much, the quantity, how much can be given to a person so that effects can be seen. Let's say we want to carry out a survey. Let's say we want to carry out a survey on how many tablets of Piriton a person can get so that effects can be seen. Let's say you give a child 1 Piriton, kaja Piriton kamozi, mamupas amwa. And then the child plays the whole day. Then they're going to say, oh, so 1 is not enough. The following day, let's do 2. Until you see that you reach a point where you've given the child Piriton, he'll just sleep and then wakes up. In a moment when you go above that, you find that the child might even die. So we'll be looking at 3 levels. 1 level, when the dose is given, then there is no response given, or there is no response, or there is no effect observed. We're going to call that as a threshold. You give the drug to a person, no response whatsoever. We're going to call that as a threshold. We'll look at another level where this drug is given to a person, the effects have been seen to the max, where maybe the child sleeps the whole day. So you know that this is the maximum dose I can give. The moment you give dose beyond that, you find that now someone might even die. So that is the dose response. I'm talking about the amount given as well as the effects that are produced thereafter. And after this, we even come up with graphs. How do we certify that? And then as a toxicologist, we'll be able to even come up with how much drugs can be given to a person, which is a safe, which we call human safe dose. I think we'll come and look at that later. Then the other one here says that dose response describes the effect of toxicants on an organism caused by different levels of exposure. Something that I've talked about. Yeah, and this one here, I also talked about it in a different way. Then you're saying here that the greater the exposure, the concentration or the dose of a toxicant, the more severe the response in an organism is. The more the severe the response is, or the effects will be observed. I think I even talked about that. Like when a person takes two stuff of Piriton, you find that it may not be enough for you to observe that someone did take Piriton. But beyond that, you're likely to see different effects. Now, let me talk more about this in a dramatized way. Back in the days when I wanted to become a Schminer, I really wanted to work from the copper belt Lumwana to be specific. Because back in the days, some of us that grew up in the village, the people that we saw well established are those that worked in the mine. So I had that in mind to say, I think once I work in the mine, I'll have some good cash, I'll get established and stuff like that. So when I went to the copper belt, I did the civic course and stuff like that. Then they told us something to do with the exposure to the dose. That in Lumwana, they mine this precious element, I don't know how true it is, uranium. Now, uranium is one of the radioactive elements that we know. And too much exposure of that, there are a lot of effects that one might encounter. So they told us that people that work there, they have badges. These badges are able to detect how much you are exposed to the radiations. We're talking about having a certain limit, in so much that even if you are exposed to them, you can't even have side effects thereafter. So there is that instrument that measures how much you are exposed. So they must be able to set a limit to say, once you go beyond this limit, my dear, you find that you are likely to have children with abnormality, Down syndrome and stuff like that. That's what this point is trying to say. So it's important that we learn, we exhaust on the point, and then we link to what happens in the outside environment. The greater the exposure, we've heard of certain prostitutes in certain areas where they go do their normal ways of doing things in the night, but they know that once my child wakes up in the night, will come and ask, Mom, where did you go? So what do? They give piton to children. Now, in the moment that a mother gives this amount of piton to a child, the following morning, the child asks Mom where she went. The following day, we increase so that the child sleeps much longer. Okay. Okay, blah, 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 blah. We'll come and talk about this in the next slide. Yeah, now we're saying that these, like I'd said, different amount of concentrates are likely to bring about different effects, and different pollutants are likely to bring about different effects. There are certainly, I'll talk about juice, too much of beer, as if I am much into it. I'll talk about juice. There is a certain type of juice. Let me just try to talk about this in this way. Let's say this is, let me just try to draw the, okay, let me just change the color. Let's say this is a cup where we want to put juice. We've got two identical cups, same type. And then we say we're going to put a little bit of water in here. Okay, we put water here and water in there. So we've got the test tube A and we have test tube B. These are two, not test tube, these are two bigger that we have. And then we say, okay, then we're going to have two different juice brand. To have cordial juice, cordial drink, and then we have granadilla, which is just same amount, different brands. You find that what will happen is that one of the two may be sweeter or may produce the solution, or may produce the one which is slightly sweeter than the other. Why? Because of difference in concentrations. Now, the ones that, if you're talking about the pollutant which is likely to bring effects within a short period of time. They'll tell you that, Mwana, don't play with this. The moment you expose it to that, it won't even take, like Ebola, the way it was in Congo, it was so deadly. So in a situation whereby you are studying such pollutants that are likely to kill living organisms within a short period of time, you need to come up with a certain test method, which they call acute. This acute test method or test study is a study that deals with the pollutants that produce results within a short period of time. And then we also have another one. This one takes a little bit of time, it's friendly. This one is called chronic test study. This one takes a little bit of time, and this one is easy to manage. This one is very easy to manage. Like HIV, that's why they're even able to manage it in that way. But if Ebola was to persist in that land, it would have claimed a lot of people, because it doesn't give time for you to.
Sorry, Mr. Kunda. Since you're saying the chronic test, how accurate is a chronic test?
Sorry?
You're talking about a chronic test, like you are saying, no, that's why they're able to detect now HIV is better, it's being controlled in the fact that they're able to do chronic tests. How accurate are chronic tests?
These ones, when it comes to accuracy, we may say they're a little bit accurate in such a way that it gives you. No, I think this one is okay. Let me answer in the best way. I think the ones that are more accurate is the acute when it comes to actual tests, and I'm going to explain on that. The acute is though it may look urgent and stuff like that, but it's a little bit accurate. Why? Because when you are studying using the acute test, let's say a person dies within a short period of time, then you want to carry out an acute test. We go on specific body organisms such as the brain, the kidney. Those areas are specific. Yeah, but yeah, I think that's the reason I might bring out when it comes to accuracy. They are able to detect, because if a person takes poison and then he dies within a short period of time, the brain should have an information on what has caused the death. But when it comes to chronic, because this takes a lot of time, so you find that it becomes even difficult to tell the cause of the death. I will still come around and say something different. Yeah, why am I saying so? It's because I was just trying to bring in the understanding of how long it takes for the effects to be seen. That's why I brought in the issue of HIV. But when it comes to tests, let's say someone dies, then you want to carry out chronic tests. You find that maybe this person has been suffering from this disease for a very long period of time, because of course chronic is to do with the one that takes a lot of time. Then you find that this person has been suffering from this disease for a very, very long period of time. And then this person dies. It may not be, the data we obtain may not be accurate, because within that period of time the person has been suffering, there could be other diseases which have contributed to the death of that person. I don't know if you are seeing the angle I'm viewing it from.
Yes, I am. You can go ahead.
Yeah, that is the angle I may bring it to you in that way, because acute, someone who was just very healthy, maybe even he did the body checkup from the clinic maybe the previous day, then he's exposed to this pollutant, he dies. It becomes easier to tell once you carry out the acute. Now the chronic, this person has been suffering from this pollutant within a very period of time. Even if you carry out a chronic test to establish the cause of the death, you find that maybe there are other diseases. Yeah, that is the things I wanted to talk about. Of course, we come and look at the differences between the two in a detailed way. Okay, so we're talking blah 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 blah. Just about certain points I'm focusing on. Okay. Observable, okay, maybe I can talk about okay, this one, because there was a question which talked, I don't know if you saw it, there was a question which was talking about how can you drive the dose response from variable tools. Yeah, maybe I will come and talk about this one highlighted when we look at when you look at maybe the LD50 and the LC50 somewhere. Sorry. Yeah, I think maybe we're going to look at this point when we reach the dose response curves. Yeah. Okay, maybe let's look at that here. We're saying that the objective of these tests is to estimate the possible range of concentrations that are likely to produce the results in a readily way available. Okay, this one I'll also talk about it when we go to the actual tables. Okay, now here it's just important so that I link to what I'd said earlier, that when we use, or when you hear of the word dose, when we hear of the word concentration, how do we relate this information? At times the question may not come in a plain language. The question might come in form of a graph. Maybe they might just put the heading LD50. Then they ask you, how is that pollutant being studied? Are they studying the dose? Are they studying the concentration? Or even if they don't do that, they just put these units. How do we know? Are we studying is it an LD or an LC? Yeah, so this is the point I wanted to say. But these pollutants, some of them are very small in quantity, but they can produce results in a massive way. And there are others, you need to take a lot of them for you to see the effects. Different pollutants produce different results at different time interval during the exposure. So saying that they are for a dose, this is for a dose now. Yeah, of course, the word is there, dose. Yeah, so we are saying that for smaller ones, we go for milligrams. Milli, that is 100. So when you have 1 gram, then you divide it into 200 equal parts, you get to have milligrams. Of course, bigger ones may be expressed in terms of kg. But now, remember, this dose response is talking about how do we estimate the amount of dose to be given to this person with respect to the body mass. Remember, I even said that at extreme levels, when someone is sick, they might even need to take the body mass. Yeah, they might even need to take the body mass. So this is what the point is trying to talk about. To say at times, the measurement may be expressed in milligrams per kg. Milligrams of the toxicant administered to this living organism per the amount of the mass, per the mass of that individual. If we don't want to go by mass of an individual, we may go by the amount, let's say the amount of blood. Yeah, we may talk about the amount of the milligrams given to this person per the amount of blood. That's why the age, that's where the age comes in. How old are you? Oh, I'm 24. Or then the doctor is able to estimate to say, if this person health as he is looking is 24 years of age, I'm sure the amount of blood that is likely to have is so much. Therefore, you can only take 1 tablet of Panadol. They are able to do that. Why? Because they do not want to contaminate the blood with so much of the drugs. Because we know from the biochemical point of view that these drugs, some of them are made from acids. Yeah, like Panadol. I remember in 2016, 2017, 2018, we were privileged to have access to the information on how to make Panadol, which we did, except that we didn't have the machinery. We also did not have the binders to put the stuff together so that it becomes that hard. So they even told us to say, when that drug is made, of course, the way it's made, one of the reactants is an acid, but in an organic way. When that medicine is made, it has to be tested in various ways. And one of the ways in which that medicine is tested before certified being set to be sold is how long does it take for that to dissolve? So that we avoid a situation whereby in the morning you take Panadol, that Panadol has not yet dissolved. 12 hours you take another one while the first one is still in your belly. It hasn't been absorbed by the bloodstream. You take another one. So to avoid that Panadol has to be tested. So the amount of blood in the body will also determine the solubility of the drug. Yeah, so that's what we are trying to say. But again, they are saying at times, these drugs or these pollutants, these
curious.
Hello?
Can you get me?
Yes, but the voice is a bit low.
Okay, I was saying, can you get me?
Yes.
I was saying, how long does Panadol get to dissolve? I'm now curious.
How long does Panadol take in the body to dissolve? There, I may not give a definite answer because Panadol, the solubility of the Panadol depends on one, the body temperature. You know that, yeah, you know that, sorry, you know that the temperature is one of the factors that affect the solubility of the product. Yeah, so one, it depends on the temperature of the body. Two, the amount of fluids in the body. Those are two things that affect the solubility of the drug, not only Panadol, of the drug. Yeah, so unless we look at okay, so they're saying that the tablet of Panadol for a person who is 25 years with the normal body temperature, it's likely to take 2, but dissolving within, I think within a minute, Panadol dissolves. You've never seen a situation whereby a person, especially kids, this person is given the drugs in the mouth, before the person swallows it as dissolved. You've seen that, eh?
Yes, I have.
So dissolving doesn't really take time, but being absorbed from the alimentary canal so that it goes into the bloodstream. So within 2 hours, it has to be absorbed into the bloodstream. Have I answered the question?
Yes.
Yeah, so solubility doesn't really take time, but being absorbed. Of course, there are other drugs that might take longer than that. So those are some of the things that that we need to know. Now we're saying for those ones, so for such, for the pollutants that are able to produce results within a very short period of time, when you are trying to give when you're trying to quantify, you need to give one, the amount of pollutant, if it's a dose, per the body mass, per hour at times, per number of hours. From the time this person, that is of course for accurate studies, from the time this person was exposed to such pollutants, how long has it taken for the effects to be seen? Those are some of the graphs that we are likely to see. The mass of the dose, the mass of the body, as well as the number of days for such a drug that produces results very quickly or effects very quickly. I don't know, maybe I'm too fast.
No, yeah, okay.
Okay, now we go for the concentration this time around. The concentration, this is still the dose. This is still the dose. Still the dose. Now they are saying for smaller quantity, for smaller quantities, we go, let's say, this dose. And let me say this dose is very small, and then it has been given to someone. Now you want to measure. Okay, let's talk about the environment as a point on top indicates. Let's say this pollutant. Maybe before I go to that, before I even go to the environment, I like giving an example of a human being, because these are some of the things that we encounter in life. This person has taken me, let's say, at Amwa logo. It depends on how dangerous that substance is. Some would say mupase milk. Others will say mufake ni kudrip ya mazi. So that the moment that is pollutant is absorbed in the body, they'll find there's a lot of water. As a result, the effect becomes less. As a result, that pollutant will be diluted. So now, if you are trying to give an indication to say, let's say now from the environment, you have this pollutant from, let's say, a point source. I don't know, do you still remember the point source and 9-point source? From a point source kind of pollution, now you want to let go of such a pollutant into the river. So you need to estimate how much of the pollutant that must go into the river with respect to the amount of water. With respect to the amount of water present, so that even if a person drinks, if the amount of pollutant in that river is very small compared to the amount of water present therein, then there can never be diverse effects expressed. So when the amount of dose is measured in milligram expressed per milliliter of the solvent, that is the same as ppm, particle per million. ppm is one of the measurements that are used in analytical industries. ppm, I'm just looking at the VATRA, the nutritional content, the mineral water, the composition of the ingredients. These ones are expressed in milligram per liter. Yeah, but some of the brands of water, the sodium, the chlorine, and the other ions are expressed in ppm. So when they say ppm, they're talking about per milliliter, how much of such solids are there. So whenever you see the ppm, meaning the quantification was done milligram per mils of the water present therein. But of course, we also have at times units that are items that are very small, microgram per liter. That is abbreviated as ppb, particle per billion. Then we also have the smallest, which is the nanogram. Nanogram, very small. Nanogram, meaning 1 gram to be divided by a number that has got 9 zeros. That's a very big number, because 3, that is 1,000, 6, that is 1,000,000, and now I don't know the name of that number that has got 1 with 9 zeros. So when you have a gram being divided by that smaller stuff being expressed into a liter, that's what we call PPT, particle per trillion. But this one is not common. PPT, PPB, no. Mostly we use PPB. Mostly we use PPB. Okay, so that is the other thing that we need to know. Some of these things here may be important also, just for the sake of understanding, that milligram per liter, we're talking about the solid being expressed in terms of the liter of either the water or the body fluid. The milligram per gram, we're talking about the mass administered with respect to the body of an organism. And then this cubic milligram per cubic, we're talking about now the amount of solids that are in the air to do with a pollutant that we inhale. These are some of the things that are used when you are collecting the data. And now we can go to, okay, blah, 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 blah. Okay, so there's need to establish some criteria to base the relative safety of a chemical and toxic or toxicant. Okay, several methods. Okay, okay, so blah 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 blah. Which one is important here? Okay, we are saying we can estimate how much of the effluent can go into the water. Let's say you are running a factory, then you want to know if the effluent coming from the factory, let's say the production of, maybe let's say the extraction of oil, cooking oil from sunflower, we expect to have some stuff which we can declare as of no use. So how do we get rid of that? Mostly the vulnerable dumping site are the rivers. So how do we know that if we put this pollutant into the river, it's not going to kill the fish? Because remember, even the other day, not long ago, we're looking at the BOD and the COD, and they are brought about as a result of these things that we put in the waters. So how do we say that this amount of effluent is safe to be ejected into the river? So this is a formula that we use. 100, that's just a number, multiplied by the volume of the effluent that you are going to eject into the river, divided by the same volume that is on top. You put it here, the volume of the effluent plus the volume of the water in which you want to have that the volume of the water which is going to dilute the effluent. That's why I even said to say that the amount of fluids even in the body is very, very important. That's why certain diseases such as the headache are caused by the lack of water. Water is very important in our bodies. So that's a formula that we can use to detect the concentration of the pollutants that have been ejected into the river. You're able to tell, to say, in case such reports come to say, no, that the river the fish was drying, people were drinking from there, were developing some stomach and stuff like that. So this is the formula that you can calculate to detect how safe that water is, based on the amount of effluent that was poured into the river per the amount of water present therein. So yeah, so that is the point here, saying the aquatic toxicity tests, talking about the organisms that are exposed to chemicals directly or indirectly, yeah, by those chemicals that are put into the water where they live. And yeah, there are some creatures that are so sensitive to that. You find that once you put in a lot of stuff into the river, the BOD and the COD stuff taking place, the level of dissolved water reduces. As a result, you just see the fish dying or some sensitive organisms dying. So once you see that, it's an indication that there must be something wrong with the water. Okay, so they are saying that, yeah, so like I was saying, okay, so they blah, 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 blah. So saying that the effect criteria or endpoints of toxicity are used to compare chemically exposed organisms with unexposed organism measures of toxicity. So that is very important, but how do we talk about that? There are some pollutants that are present in water. Some things may be declared as pollutants to certain species, and the same pollutant may be declared safe to other species. So in an environment where we have this pollutant commonly in the environment, how do we get to know, or how do we get to measure how much might have caused the damage to this organism? That's the point they are saying. You need to get, okay, maybe not even that. The good example that I can bring to you is, okay, I may look for the example in the later stage. Yeah, but we're talking about, there are times you are able, analysts are able to make comparisons between the organism which has been exposed to the pollutant and the other one which has not been exposed. And when you do that, you find that some of the conclusions you are going to get are, one, you are likely to get an equivocal. What does it mean? Results are not clear. Results are not clear. How? Maybe you get the unexposed organism and the exposed organism. You try to compare. Maybe the difference is slightly small, but this organism which is exposed to this pollutant has died. The other one is still healthy, but the comparisons in the amount of the comparisons is very, very small. Then results may be not clear to give a vivid conclusion. The other one is this one here, reproducibility. When you say results are being able to be reproducible, they are reproducible, what does it mean? You are getting results, same results every now and then. And this one is very important. The productivity in the industry is very, very important. We want, or they want, to be getting results every now and then. That is the reason as to why at times you do the experiment once, you see the results you get, you do another one so that you are able to see which results you can call errors. We want to get the same results. Why should we test the same water? You test the amount of chlorine in ppm. This one says it's about 5.0. Then the other one says 12.8. That's why the issue of accuracy and precision now comes in. We believe in the reproducibility. I didn't know this term. That is the reason as to why I'm the one who even added this thing here. I didn't know this term until when I had gone for interviews with the Chambish Corpus Meota. They wanted the laboratory scientist there. So I went there, and then they asked me. There were some terms that were there in the oral, in the quiz, in the written interviews that we had. Define the word reproducibility. After that, then they started giving us ideas why certain terms are used in analytical laboratory areas because of the accuracy. They want when a company is being established, they bring the samples to you to work on them. They want the reproducibility. It tells also how effective the machines are. Now we are saying that when you are doing, when in case in case you want to compare the exposed and the one that is not exposed, which organisms do you go for? Let's say the water pollutant. These are some of the organisms that you are likely to go for, and there are reasons for that. But above all, we need to make sure that the organism one gets is that one which is very sensitive to such a pollutant. And some of these organisms that are written here are of that character. You need to go for the one that is very sensitive to a pollutant. Because if we have an environment whereby these organisms that are in such an environment, it takes time for them to respond. Like, let me not even go to organisms, human beings. Some take time to respond to the presence of dust. They don't even get flu. You just cough once off the shoulder, he goes. And there are some, just a single exposure of few particles of dust, they catch flu. So such are the ones that do give a better indication that the air is polluted. So it's to do with the life in the pollutants in the river. It's better you go for such organisms. Now, them being easier to respond to such, maybe because of the way they breathe, like the fish, because the fish has to allow every water to go inside the mouth. And believe you me, if that water is polluted, you find that the fish will come in contact with such a pollutant in an inside environment easier than maybe the hippo. So you can't pick a hippo and start testing it. Because maybe one, the skin and even the environment and the way it is, its body mass is big and stuff like that. So we must be very selective when we are looking for species to test in an environment. And for this creature, these are some of the things that given out. But the question might come to say, in such and such a river, a certain pollutant was reported. And now you, as an environmental observer, you are trying to establish the cause, or maybe the type of a pollutant present therein. And then your observer says you need to go for such a creature. Then the question might be, explain the reason why it is advisable to go for that and not the hippo or the crocodile. So these are some of the things that we might bring out. And in an environment where such a question comes, and there are a lot of answers, it's better you go for the ones that you can easily remember. And one of which is that maybe this one, because they are very sensitive to any contamination. Like I said, someone who catches flu easily is the one that we can use even to detect if that is possible. If we had such a test before, maybe before science advanced, you just get someone and put him in the room. If he comes back, observe him 2 minutes, he doesn't have flu, then you know that it's safe. You can't get someone who doesn't get flu. So yeah, I hope you understand what I mean. Yeah. And then the other one is that, let's say this fish that we're talking about is on demand, because there are some species that are not common. How do I put it? There are some species which are found in water, but they are not eaten by most of the things that are found in the water. How do I say it? Let's speak of a crab. That crab, I don't know if there are other other animals that take pride in eating crabs, just the way they look. So if a crab is the one which is sensitive to such a contaminant, it becomes easier, or it becomes safer for other animals. But if small fish is the one, if the small fish is the one which is sensitive to the contaminant in water, and then that fish gets the contaminant, and it's on demand. The moment that fish dies out of the pollutant situation, there's going to be another fish to eat it. The pollutant has gone to that fish. Another fish eats that fish. That cycle goes. So you need to make sure that you go for such species so that you put the chain of contamination so easily. That's what this point is talking about here. You go for that because they are very important in the link for the food chain within the water. Once this one is contaminated, this dies out of contamination, this one eats. The one that is on high demand, you find that a lot of creatures will suffer the consequences in an indirect way. With all that said, we also talked about the body size being important on how to cope up with the situation of the pollutant. Maybe we can't go for the hippo because the hippo is way too big. Even if it takes a little bit of some milligrams of the pollutant, because of the body size, that pollutant will just be diluted in the body. But if you go for smaller creatures, any small amount of pollutant administered, the effects are likely to be seen so easily. yeah, so yeah, these are some of the things that you can bring about. You can talk about providing an important link. You can talk about that. You can talk about those that have got short life, among others. Okay, Muriko.
No, I'm there. I'm just getting zoned up. I think I'm tired, but yeah, I'm there.
Yeah, maybe we stop here.
But you're recording it, right?
Yes.
Okay, okay, then we can stop here. You share the recording.
Okay.
But at least I've gotten the concept where dose and the concentration is deriving from, and the difference between the dose and concentration.
Oh yeah, and then I saw a question she was talking about this, the acute and the chronic.
What's the? I think I also saw that in a question paper.
What's the
That's a
difference?
question that I was asking you about earlier on when I asked.
Oh, okay.
But I think this, I'd like it on a fresh mind.
Oh, this, yeah. Even with Rebius, with him, we just ended here. We just ended on the, if you look at the first recording that I sent, we ended on this. Because I knew that understanding this, you need a fresh mind. Yeah. Yeah. So I don't know when we can come finish it up.
On a Sunday. So let me talk to Ravias. I think Sunday will be good.
Okay. All right, boss nishi natatara sana.
Okay, Bakunda, thank you. Just share the recording with me.
Nesampare kentu pikako.
Okay, bye.
All right, bye.